guys, let's move on with the module number 3, which is number systems, LCM and GCD. So let's move on with the number systems first. I'll give a brief explanation about the number systems. So these are the basic number systems we make use, which are, there are 4 different types of representation that we have to majorly consider. One is binary, octal, decimal and hexadecimal. The base values of these representations are binary, the base value is 2, octal, the base value will be 8, if it is a decimal, base value is 10, and if it is hexadecimal, the base value will be 16. Now we'll see how can we convert from one base to another base. Look at this one. Here we're gonna convert decimal to binary. For example, if the binary number is 10.25, whenever we're gonna say it's a decimal number, its base will be 10. Let's see how can we convert this decimal number to binary number. Now the process is, if it is a decimal number which has a base 10 and we have to convert into a binary number which has a base 2. Now that we have, if the decimal number does consist of a fraction part, we have to divide it into 2 parts. Now 10 will be the first part and the fraction part is going to be the second part. So we have to divide them into decimal part, integer part as well as fractional part. So the integer part has to be divided with 2 and fractional part has to be multiplied with 2. Clear? Now let's see. Now here 2 is going to be divided with 10, right? And we're gonna get the coefficient value as 5. Again it has to be divided with 2. Now here the remainder is 0, and if we divide this 5 with 2, the remainder will be 1, and again the 2 has to be divided with 2, again the remainder is 0, then 2 has to be divided to 1, right? So that will be the, until you reach 1, we're going to continue to reach 0 or 1, we have to continue this process. And the most important thing here, these reminders has to be taken in reverse order. So this will form the binary number. Clear? So whatever the reminders that you get when you divide the given decimal integer part with 2, with base 2 of the binary number, we have the reminders which we get will be the binary number, and we have to consider them in the reverse order. So the binary number for integer decimal number 10 will be 1010. Should not take it as 0101, that is wrong. So we should consider in the reverse order. The binary number will be 1010, right? So with the base 2, because it's a binary number. Now for the fractional part, as we discussed, we have to multiply that with 2, right? So now here the fractional part is 0.25, so it will be 0.25 into 2, which will be 0.50. Then again you will get 0.50 into 2. Now you get 1.00 until you reach 00. In the fractional part, you have to keep on iterating this process. Now here you have to consider 01 as the binary number, and one more important thing is, here you should not take it in the reverse order, you should consider them in the proper order itself. From top to bottom you have to consider it, not from the bottom to top, just like in this particular case. Clear? So now what will be the whole binary number for 10.25? So it will be 1010. Then we have to add this 01 to it, so it will be 1010.01 with the base 2. That will be considered as the binary number of 10.25. So this is how we're going to convert decimal to binary. So let's move on to the next one, where we're going to convert binary to decimal. Now let's take the same example. So here it is 1010.01, which is a binary number. Now we have to convert that into the decimal number. So in this mechanism, what we have to do here is, now What is the count of the integral by numbers here? 1, 2, 3, 4, right? So we have to start with 0. So let's take it in the reverse order over here. So each and every binary number has to be multiplied with 2 with a power. That power value is going to be incremented from 0 to 1 over here, right? So now let's see. So let's consider here. So 0 into 2 to the power of 0. Then this power value is going to get incremented 1 into 2 to the power of 1 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3, right? So this is a mechanism that we have to follow. Now what about the fractional part? In the fractional part, we have to start decrementing the values from 0. Yeah. So now look at this. 0 into 2 to the power of minus 1, again plus 1 into 2 to the power of minus 2. Now this will yield your decimal number. Now look at this. 8 plus 0 plus 2 plus 0 plus 0 plus 0.25, you get 10.25. That will be your decimal number. So now let's move on to the next conversion, which is decimal to octal. Again, already you know that. So now this is the decimal number, the same mechanism that we're gonna follow here. So now here, see 10.25 to the base 10, and 10 is the decimal number that we have to consider, and 12 will be its octal number. And the fractional part has to be multiplied with 8, which is 2.00. So you have to keep multiplying the fractional part with 8 until the decimal number is 0.00 obtained. Clear? Here we're gonna follow the same process which we have discussed for the first one. The part which we have discussed over here, the same mechanism we're gonna apply for decimal to octal. Again, octal to decimal. Again, the second part which we have discussed, right? Binary to decimal. This same mechanism we're gonna follow for this octal to decimal, right? So where we have to perform 8. So 2 into 8 to the power of 0 and 1 into 8 to the power of 1. Then for the fractional part, you have to decrement from 0, like 2 into 8 to the power of minus 1. So the yield result will be your decimal number. Now the next one is pretty different, which is hexadecimal and binary. Hexadecimal, you already know. In hexadecimal what happens, so it consists of a different representation. So 0 1 2 3 4 5 6 7 8 9. After 9 you will be having A B C D E F, right? The next proceeding number will be 11, 12 and so on, right? So in the hexadecimal what happens, here we're gonna make use of this value, which is 3k to the base 16, and we have to convert into binary equivalent, right? So now let's directly look into the binary equivalent table, and you already know that how can we form these binary numbers, which are 0 0 0 1 1 0 1 1. Then after that we will be having 1 0 0, then 1 0 1. These last two numbers will keep on varying in the binary numbers, right? So now 3, what is the binary equivalent of 3? You can see 0 0 1 1. So you will get 0 0 1 1. Then the binary equivalent of A, which is 1 0 1 0, that will be your whole binary equivalent of hexadecimal numbers, right? So this is about a simple explanation to it. Now let's look at a program where we have to discuss about the 31st program, which is converting decimal number to binary. Already you know the process of it, right? So if the decimal number is 10 and its equivalent by number is 1010, you have to keep on taking the reminders when we divide with 2. right? So firstly, what we're gonna do, we're gonna take an array, right? You already know about the arrays, right? So arrays are contiguous memory allocations where its index value is always begin with 0, which consists of similar data elements. So here the decimal number which is given will be 10, and the count value I'm going to take is, initially it will be 0. So in this case, what I have to do here is 0 into 2. First of all, here what we have to do, we have to keep on dividing this number with 2, right? So that's why what we're going to do, we're going to place those numbers, those values, equivalent bind numbers, in an array. So that's why here base index will be 0, right? So that's why we're going to take the count value as 0 over here. Now let's see what's the first number. First number will be 10 over here. Now 10 modulus 2, what's the remainder that you get? 0, right? In bin of 0, I am going to store 0. That will be the first number that I am going to store, right? Bin of 0 equals to 0. Now I have to update the number, right? Now what will be the number that is going to become over here? So number equals to 10 divided by 2, which is, what's the value that you get? 5, right? Again we'll go for the next iteration, 5 greater than 0. Again it will become true, right? Now 5 modulus 2 and the remainder value will be 1. Then again I am going to update 5 by 2. Now the value is going to be 2, right? Again I am going to increment the count value. Then again 2 is greater than 0. Again it is going to become true. Now bin of 2 equals to 2 modulus 2, which will be again 0. Now number equals to 2 by 2, which will yield 1 as the result. Again I am going to increment the count by 1. Now number is greater than 0. Now here 1 is greater than 0. Again it is going to become true. Now bin of 3 equals to 1 modulus 2. Now here the value will be 1. Now again number equals to 1 divided by 2, which will become 0, and count value will be incremented. Now 0 greater than 0, obviously it is going to become false, right? So now inside array we got 0, 1 and 0, 1. Now we have to display that in reverse order. Now let's see how can we reverse an array. So what you have to do, initially this count value, now it has become 4, right? It has become 4 over here. Now what we're going to do, initially I am going to take I equals to count minus 1. Now I value is going to become 3 because index values that will be 0, 1, 2, 3. So I have to start from 3, right? So that's why I am going to take I equals to 4 minus 1, where I value is going to become 3. 3 is greater than or equals to 0, and here 3 minus minus bin of 3. So first it is going to display 1, which is bin of 3 value. Then it is going to display bin of 2 value. Then it is going to display bin of 1 value. Then it is going to display bin of 0 value. Then condition is going to become false. So that's how you're going to convert this decimal number into binary number. So let's try to run this program and let's give decimal value as input, and you get the binary value as output, which is 1010. Thank you guys. Let's see you in the next video.